7-3, we're looking at rational exponents. So that means fractional exponents. The first thing I want you to look at is doing these problems in your calculator. So type in 4 to the 1/2, 9 to the 1/2, 25 to the 1/2, 144 to the 1/2, 8 to the 1/3, and see what you get for numbers. So I'll get out my handy calculator here. 4 to the 0.5 gives me 2. 9 to the 0.5, 3. 25 to the 0.5, 5. 144 to the 0.5, 12. And 8 to the 1/3, 2. So the big question here is, what's another way to write x to the 1/2? We have 4 to the 1/2, we got 2, 9 to the 1/2, we got 3, 25 to the 1/2, 5, 144 to the 1/2. So if we look at the 1/2 power, it's really the square root of x. So the 1/2 is really the square root. We can put a little 2 in here. It's just not written. So the square root of x. This can also be written as, so if we go down the line here, I guess it would be square root of 4, square root of 9, square root of 25, square root of 144. And then this last one's tricky because there's a 3 there. So we have to put a little 3 inside that little spot there, the cube root of 8. So square is square root, or 1/2 is square root, and 1/3 is cube root if we have to the 1/4 power. So if it's x to the 1/4, we would get a little 4 in that box. So the first part of this section is just rewriting it. You don't have to do any math. You're just switching it from the half exponent to the square root or back and forth. So if we look at the first one, we have to first decide, is this 1/2 power on the x, on the 5, or both? And in this case, it's on just the x. So this is 5 times the square root of x. That's all you have to write for that problem. When it says rewrite in radical form, you just switch it so that it has a radical. Now if it has a radical, then you write it in exponential form. So this is to what power? 1/2. So it's 18b, and all of that is to the 1/2 power. If it were 18 times the square root of b, then this would be 18b to the 1/2. Notice here how the 1/2 power is on the b. Here it's on everything. That's the first part about today's stuff. The second part is actually simplifying. So here we have what number times itself 3 times gets 343, and what number times itself 6 times gets 64. So you could scramble around on your calculator and look for, well, where's that cube root button? And on this calculator, you'll find under math right here, x root and 3 root. But if you wanted to make yourself a little bit easier, we can write this as a fraction. 343 to what power? 1/3. And 64 to the 1/6. Now type this into your calculator. We know where that button is. 343 to the, to the 1/3 power. Be careful in your calculators. Make sure, I didn't do it this time, make sure you're putting parentheses up there. Because in your calculator, if you don't, it'll do 343 to the 1st. It'll do this, 343 to the 1st times 3. And we don't want that. So make sure you put parentheses around here. So the answer to this one is 7. And if we do 64 to the 1/6, 64 to the 1/6, we get 2. So this tells me that 2 times 2 times 2 times 2 times 2 times 2 times 2, 6 times, is equal to 64. And then the last part of today's stuff is solving equations with exponents. So you could go and guess and check. Guess and check. See if you can find an easier way to do these problems. This one's kind of tricky, but this one you should be able to get. Do your best in these two. I'll pause it here, and then I'll come back and do it again. What we need to first do is get the bases the same. So 2 to the x, 2 to what power is 128? So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. Oh, there we got 128. So 1, 2, 3, 4, 5, 6, 7. 2 to the 7th power is 128. So x equals 7. Because the bases are the same, that means the exponents need to be the same. We need to do that same thing over here. So what we're looking for is 4 to the x minus 3 equals 4 to some power. So if we do 4 times 4, that's 16. Times 4, that's 64. Well, we're already bigger. So that's not going to work. Now we need to look for a different base. Well, 4 is also 2 squared. Maybe we can get 32 into a base of 2. Well, we did that over here. 1, 2, 3, 4, 5 is 2 to the 5th power. When we have a power to a power, it's 2 to the 2x minus 6. We're going to multiply these two things together. Equals 2 to the 5th. We have the same base. 2x minus 6 equals 5. Add 6. 2x is 11. So x is 11 over 2, or 5.5. So if you can get them to be the same base, you just set the exponents equal to each other. Or you could guess and check. But it's going to be hard to guess and check 5.5.